So let's talk about product development. The most fun we could have with it is that we're going to use the case study from our own company, FBB Biomed. So it all started in 1995 with my work on Gulf War illnesses. We knew that the troops were immunized with poliovirus RNA, and so our hypothesis was that the poliovirus mutated. However, the results did not exactly match the hypothesis. What we had discovered and published was that foreign viral RNA rearranged with its own host genetic material. And now it turns out that documenting the first description of taking nucleic acids out of serum and plasma, sequencing them, and matching them to the human genome, that I had just done the first genetic liquid biopsy, a term that came on later. Then I had a good fortune to reach out to one of the key opinion leaders, Professor Michael Ulrich of the University of Göttingen, Germany. Professor Ulrich is one of the top-ranking officials in the American Association of Clinical Chemistry and has been a major contributor for many, many decades. And in 2001, Professor Ulrich invited me to come to Germany to give a lecture and present my ideas and hypotheses. And I sent him the title. He said, let's have the title, your name, your position, so we can put the flyers up, send it out to the university. And I said, did you read the title? And he goes, yeah, it's good. That's what we want to hear. The title was something that was hard to get folks to believe in, that there actually was a unified theory, if you will, of human disease, or actually disease. I was fortunate enough to have the same game plan. Is when I see a medical tragedy like AIDS, like Gulf War illnesses, then this is something that should be studied. In fact, the observation is that there's a common denominator among all of these chronic diseases. You have to then create the hypothesis, is it possible to build one test for as many chronic diseases as possible? And then the first place you have to search is a reference. You have to find out what is known about your material, and you need a reference. And the reference in the late 90s really was not available until the year 2000, when the first announcement of the Human Genome Project had occurred.
Good morning. We are here to celebrate the completion of the first survey of the entire human genome. It will revolutionize the diagnosis, prevention, and treatment of most, if not all, human diseases. In coming years, doctors increasingly will be able to cure diseases like Alzheimer's, Parkinson's, diabetes, and cancer by attacking their genetic roots.
So everybody was excited about the Human Genome Map, because one might think that the two groups working on this important project had completed the map of the entire human genome. The problem is that the genes that were mapped were only those genes that code for protein. And these coding genes only represent 1 to 3% of the genome. But where is the rest of the human genome map that does not code for protein, which represents 97% of the human genome? This question is critically important because while we reduced the hypothesis to experimentation, the results were difficult to interpret because the critical biomarkers were the non-coding genes that were not mapped. These non-coding genes were in overabundance in persons with Gulf War illnesses, multiple myeloma, multiple sclerosis, AIDS, mad cow disease, and cancer. Where will this go? The original lecture I gave in Göttingen in 2001, where I said there is a unified theory behind disease, and you should start with retroelements. This will move us into neurologic disease. I'd love to go after Alzheimer's, autism, Parkinson's. So let's get back to product development. What is the FBB Biomed product after all these decades? The product is a test for the body's RNA operating system, which makes this product the first liquid biopsy for the early screening and definitive diagnosis for multiple sclerosis, Parkinson's disease, and Alzheimer's disease.